Hi, this is Mr. Ward, and welcome to the Algebra Exit Ticket 33.3 video key. Currently for A block, though I might use it for a different block. So here we go. Based on some questions that people asked at the end of the last class, I'm going to give you a reminder. To get the x-intercepts, factoring an equation and making it equal to 0 is a good approach. So what are the x-intercepts of x squared minus 4x minus 45? Now, of course, you could use the quadratic formula for this if you work that out, but in this case, factoring is probably the easiest thing. So we're going to factor this. There's definitely going to be an x in both of those, and it's nice that there's a lead coefficient, but it's just one. We need two factors of negative 45. So here we go. Negative 45 that add up to negative 4. So they add up to negative 4. So they're factors. Okay, so one has to be negative and one has to be positive because that's a negative product. And the negative one is going to be the one that's farther from 0 because our sum is negative. So what are some factors of 45? Let's just focus on 45 and ignore the negative for right now. Well, there's 1 times 45. There's 3 times 15. And there's 5 times 9. Well, 5 and 9 are 4 apart from each other. So if we said positive 5 and negative 9, those would add up to negative 4. So x minus 9 and x plus 5. Doing this last bit doesn't quite work if the lead coefficient wasn't 1, but it works when it is. So we've got x minus 9 and x plus 5. Okay, now what are the x-intercepts? If we say that this equals 0, then we can say, all right, what x value would make x minus 9 0? Well, 9 would make that 0. So x could be 9 because 9 minus 9 is 0. And what x value would make x plus 5 equal to 0? X could be negative 5 because negative 5 plus 5 would equal 0. And if we can make either of these factors equal to 0, by changing x into something that makes them 0, then it doesn't matter what the other factor is, the whole thing multiplies out to 0. Then how do we get the y-intercept? So a reminder, replace x with 0 and see what y equals. Basically, when you replace x with 0, you're going to see what survives in the equation because 0 is the great annihilator. So there's the equation, and I'm going to replace x with 0 wherever it shows up. So 0 squared is, of course, 0. Negative 4 times 0 is just 0. So we got a whole lot of 0 minus 45. So that's just a whole lot of 0. So really, when you turn x into 0, all you're really going to care about is the c part of this equation. Remember, a is 1, b is negative 4, and c is negative 45. So because the a and the b are just going to get annihilated by x being 0. So the y-intercept is going to equal negative 45, which is the c part of the standard form. Our y-intercept will be at 0, comma, negative 45. I will remind you that back here, our x-intercepts will be at 9, comma, 0. X comes first, and negative 5, comma, 0. I've seen a little bit of reversing that showing up in some of the testing out. So watch out for that. Same with the y-intercept. Y comes second. X will be 0 in a y-intercept. Which of these would be the simplified version of the square root of 75? So that's the square root of 75. Well, 75, we have the square root of 75. That's going to equal the square root of 25 times the square root of 3, because 3 times 25 is 75. We can get the square root of 25. It's going to be plus or minus 5. And 3 has to stay in square root jail. Poor 3. There it is. And so we're going to have plus or minus 5 square root of 3 right there. Okay, we got a little reminder for you for number 4. I just want you to tell me what A, B, and C are in this equation. If you feel like you can work out the quadratic formula value based on that, do it. I encourage you to do it. I'm going to do it. So A is going to be 2. So A equals 2. B equals 3. And C equals negative 9. So I'm going to copy all of that. And I'm going to actually go into a Desmos to do that quadratic formula thing. So here we go, Desmos. And of course, the quadratic formula is, I'll put this in parentheses to begin with, negative b plus or minus, I'm just going to do the plus version first, the square root of b squared minus 4ac. And that's all over 2a. And now I don't need the parentheses anymore. Let me make that a little bigger so you can see better. Now I know from here that a is 2, b is 3, and c is negative 9. So a is 2. So I'm going to replace a with 2 wherever it shows up. Okay. B is 3. So let's replace b wherever it shows up. So there's a 3. A 3. And c is negative 9. So let's replace c with that. So there's a negative 9 here. Okay. Now, Desmos is already spitting out an answer of 1.5, so that's good. But let's actually work through this. Okay. I copy pasta this. Let's see, 3 squared is 9. Just to simplify things. 4 times 2 is 8. Okay, and oops, that's not an 8. That should be an 8. And then 8 times negative 9 is going to be negative 72. So that's going to be 9 minus negative 72, or 9 plus 72, which we can further simplify into 81. Down here, 2 times 2 is 4. And now we can get the square root of 81. Okay, so this is why there's a plus and minus version. That'll be a 9. And then there's also a version where it's a negative 9. This is where it's actually the point when you might want to, you can go ahead and do the plus minus version, because you actually don't need to do it until here, until you've gotten the square root. So I've got negative 3 minus 9 and negative 3 plus 9. So the negative 3 minus 9 is going to be negative 12 over 4. Okay. And the negative 3 plus 9 is going to be 6 over 4. And then negative 6, I should say. Hang on a second. Is that negative 3? No, it's negative 3 plus 9. So that's actually positive 6. Okay. So that's a 6. So 6 over 4, or 3 over 2. And so we get 1.5 for that one. Over here, that's negative 12 over 4, which is indeed 3. Negative 3. So what this means is that when I factored this equation here, it's going to factor. I'm going to go ahead and graph this here first. So that's the graph of it. When I factor it, I'm going to end up with an x-intercept at 1.5 and one at negative 3. So there's going to be an x plus 3 and an x minus 1.5. But you notice that doesn't quite match. And the reason it doesn't quite match is I haven't accounted for this 2. So the 2 I could put right in front of the whole thing and it'll match. Now it matches. Or if I don't like x minus 1.5. I can put it here and make it 2x minus twice 1.5 or minus 3. And now it matches. And so now I factored this equation right there. All right. Let's see how we're doing. I think that's everything we need to say here. I hope that was helpful. I'm going to just go back here and leave you with what that became and what that was and where it all went. This is a good place to stop.